Welcome, everybody. Thank you for being here. Hopefully everybody's having a great day so far and are learning lots, and we'll take back the messages that you learned to everybody else. And I want to introduce myself briefly. I'm Carol Willing. I love education. I work on Jupyter.
Hi, my name is Jessica Forde, and I also am a maintainer at Project Jupyter.
Hi, I'm Erik Sundell. Previously I was a teacher, and now I work as a data engineer, but I still consider myself as a teacher because I love it. Okay.
And I want to give Erik a special shout out because he is one of our community contributors and has done an absolutely phenomenal job on JupyterHub. And it goes to show like what you can get from being dedicated to something, and it's been really a pleasure to work with him, so thank you, Erik. Okay, so the overview today, we're going to talk a little bit about the challenges of teaching computational thinking. Then we're going to talk about teaching interactivity in computer science using Jupyter Notebooks. We're going to talk also about teaching students with JupyterHub, and then how to do multi-language global instruction using Binder, and then hopefully we'll wrap up and have a good 5 minutes or so for questions, because I think that would be fun. So, take it away, Jessica.
Okay, so how many of you are educators of one kind or another? Please raise your hand. Okay. Whoa. So most of you actually probably know about these challenges better than I do, since I'm actually a data scientist by training, and I am more aware of these challenges from working through the Jupyter community. But I'm just going to review some of these things that you probably have already seen in your classroom experience. So typical challenges you might experience in education is how do you find interesting content? How do you make this content relevant to your students? How do we make this content cohesive? How do we bring these things that you already found together in a way that tells a story and conveys this content in a comprehensive way? Oftentimes, educators have minimal prep time for lessons, and maybe you even have a diverse group of students who have different language skills or different backgrounds or abilities. So this is a photo of the Data 8 course at UC Berkeley. And so this is what something might look like if you're teaching a computational course. And so adding computational resources to share content with these students adds additional challenges to the mix. And if any of you remember your experiences dealing with this, I'm sure you are familiar with these typical challenges, but I think one of the things I would like to highlight as something for us to think about during this talk is just how do we deal with getting these computational resources up and running? Because if many of you are familiar, environment setup, even for yourself, can be really hard. And luckily for me, I have lots of examples from XKCD that convey this in a very funny way, because to me, this is a very painful experience. So this kind of sets up the problem that we think about within the Jupyter community, and I want you all to keep this in mind as we go along during this talk.
Okay, so I'm going to talk a little bit about teaching middle schoolers and high schoolers, and also talk a little bit about a workshop that I taught this summer, and let's get started. So, learning and computational ideas are really the core of what Jupyter is best at. And one of the things that Herbert Simon, who is a cognitive scientist, had said is learning results from what a student does and thinks, and only what the student does and thinks. So as teachers or educators, we can guide, we can encourage, but ultimately it's up to what the student does for them to be successful. And as teachers, we want to minimize the pain along the way, because if we have hurdles or barriers, we're going to lose more students at each time. Some students learn from sort of a top-down conceptual experiences in their lifetime approach, while others are more driven by the senses and what's happening around them now. And effective learning typically includes both. When I plan workshops, I typically try and think about the audience that I'm delivering the workshop to, try and find the best content that I can find. Use recently mostly Jupyter notebooks, but some other things as well, which I'll talk about in a minute. And then I try and get feedback after each workshop and then iterate enough to smooth out the rough points that I might have had that I felt like didn't work well with the students, or they flat out told me didn't work well. One of the workshops I've done out in the community is a series of notebooks that have to do with music. And what I was trying to do was show teachers that you can have multidisciplines in a series of notebooks. And I think this one was 8 notebooks, and it started with like the theremin. It embedded some YouTube videos. It embedded some data science, digital signal processing. It talked a little bit about programming, doc strings. I used the Rise plugin, which Damian Avila has written, and that allows you to present from the notebook, and sort of guided them through that. Some of the other notebooks I had was using Music 21, was using some other Python libraries that let you visualize music, and I think what I was trying to do was combine history, music, and computing all together. So one of the things that I said is really important is I look for really good content. And if I were to do a data science class right now, I would probably look to the California Academy of Science. They have a really great open source content on taking data and making predictions with it and using it to do citizen science. But they don't have any notebooks. So to take the existing content, which is open source, and make notebooks for it, they've done a much better job than I could ever do myself to put together the information, and it gives students a way to use some of the content that they've provided after the workshop. Quant Econ, if you haven't seen it, is one of the best examples of a comprehensive course aimed more at grad student economics students, but also they've got some great tooling around it, so I encourage you to take a look at that. And we'll make sure the slide deck is up later, so if you miss a photo, please know that you can get the information still. Jason Moore, some of you were in the panel earlier. He actually has taken a classic dynamics textbook and put together a really powerful visualization for each lesson that he teaches. And this one, unfortunately, Google Slides didn't embed GIFs well, but it basically shows you how the little wagon car thing rolls along and what happens when you have different friction, or if you had different size wheels or whatever, and he's got some with springs and some really cool stuff. And I think it's important because it hooks kids, or adults for that matter, quickly, and then engages them in wanting to do additional content. All of the stuff that he does is open access, which is fabulous. And one of the ways that I learned about Jason's work was probably 2013, 2014. I took a workshop from him at SciPy, and he had a series of notebooks demonstrating what you could do with SymPy, scikit-learn, I think, and PyDy, which is a Python dynamics library. And he went through in a series of notebooks, and the end goal was to see how a human being stands and balances, and went through the different forces, using SymPy to do the equations, doing another notebook that added the calculations, and ultimately you got to the end where you had this lovely animation of the person either standing or not. I talked earlier about finding things that explore students' interests. And some good resources, not exclusively, but those are some good resources, the Gallery of Interesting Notebooks. There's some IPython books on GitHub. There's also a GitHub trending notebook search, so you can see what's very popular out there. It probably works better for those that are in, undergrad and grad school teaching, but you never know. I want to also, for those that aren't aware, pyvideo.org is something in the Python community that catalogs and offers all the Python conference videos, and both talks and tutorials. So if there's a subject that you want to learn more about, I highly encourage you to look there, and the Peter Norvig example is actually just kind of fun. Okay, so I talked a little bit about the music already. This summer, I agreed to teach a workshop for the EPIC program at Cal Poly. And when I agreed to do it, I said, I'll do interactivity in computer science. What I didn't realize when I committed to doing it was the makeup of the students that were going to be in the class. I knew that they were going to be middle schoolers and high schoolers. I knew I would have a 2-hour block with which to teach the workshop. What I didn't know was 80% of them were dual language learners, and a variety of different exposure to computer science. And I would probably have like 26 kids in each workshop, and it was just me. So not a whole lot of one-to-one initially. So I thought really long and hard, and I was like, okay, what would interest high schoolers? And I kind of came up with a schedule, which was pretty tight, but not as strictly adhered to as the timings here would think. But first I talked about the people that do computer science, and pulling a lot of different people from different backgrounds who are friends of mine in the Python community, and just sort of showed the students that there are people out there doing computer science that perhaps had a similar background that they had. We also talked a little bit about the variety of careers that students could pursue using computer science. And they weren't just technical. It's like, okay, if your interests are art, you might really like computer design, game design, graphics design. And then what I wanted to do was get their hands on the keyboard as quickly as possible and let them really go to town. So Google Doodles, there's many of them that are interactive. So what I had them do is take at least 2 Google Doodles, play with it for a few minutes, and then as they were doing that, think about the design of the doodle, what they would change, what they liked about the interactivity, what they liked about the game. And then at the end of it, we kind of did like the, shout out, okay, what did you like, what didn't you like? And I was like, make as much noise as you want. And because a lot of it has audio to go along with the video. And so that was really powerful, and that got them thinking about the possibilities. And then what I did is, instead of teaching Python, I actually took P5.js, which is a processing language that is written for JavaScript. It has an alpha interface right now, which is like a 3-windowed interface that lets them execute code and right there and see the impact in the window on the top right. And one of the nice things about P5.js is it had Spanish translations for everything, and it had built-in examples. Now remember I said we had different levels of students' abilities, so I had to think, okay, what would be suitable for complete beginners all the way to potentially kids that really were already coding in some language. And so what I would do is I would kind of guide them, sort of like we do at PyCon with some of the tutorials, start with some examples and then say, okay, this is really all I expect you to do, but if you finish that, here are some other things to look at and try. And basically, somebody earlier had said, take something, change the numbers, see what happens. I think it was Rob and his doc. And that's what they did. And we sort of spent like 5 minutes here on one topic, like maybe shapes, 5 minutes on, colors or animation. And they learned a lot just by putting their hands on the keyboards. And then I spent some time exposing them to Jupyter notebooks, and in particular, some notebooks we have on mybinder.org, which basically, I think Jessica's going to talk a little more about it later, so I'll leave what it is, but they don't have to install anything. So I knew that I needed a workshop that didn't require installation. And then what we talked about was next steps. And by the time we were done at 3 or the end of 2 hours, we pretty much had to kick them out of the room. They were that engaged. And for those of you that have taught middle schoolers or high schoolers, that's a pretty good accomplishment. It means they really were into the material. And they all left, or most of them left, with a link to a very simple Hugo website that I put up that had all the information about what they had done and where they could find it again, that had the different projects, that kind of named each thing as like a project so that they would have a sense of accomplishment as they went through it. And I won't say it's great content from like a teacher's perspective. I mean, it was good. I'm not trained as a teacher. I've just taught a lot of outreach programs for middle schoolers and high schoolers, but I took it as a good sign that they enjoyed it and they learned stuff. And now we're going to switch a little bit to Erik, who's been doing a lot of work with teaching using JupyterHub. And thank you for listening to me. Is that good?
Thank you. So I want to help you experience JupyterHub and what it can accomplish. My binder can accomplish very similar things, but if you want to have persistent storage that the users can come back to the same location and have the same files they had previously, you need something more. This is a JupyterHub that I've set up, and this way you can have this many students and they can come back, work with the same files, store the files they have, close it down, come back and have them all again. Technical details, I'm gonna leave these things out because when I worked as a teacher, I wanted this. So I set it up, but it took a lot of time, and I wish that you request instead. I want my school to have this. I want my university to have this. Start a demand for things like these. Don't take it up too much on yourself. You can try it out, but don't say, oh, this, I will maintain this for my school. I wouldn't recommend it. But if you want to leave a recommendation for someone within the school to do so, there are the littlest JupyterHub, which will be run on one machine, and you can go to this web page and you will get more information on how to set this up. And there is also the bigger JupyterHub, which is part of the Zero to JupyterHub on Kubernetes project. And there is a guide, and this guide is referenced there also. Now I will go to a demo of using this bigger deployment. So after the talk, I invite you all to try exactly what I'm gonna do right now. And hopefully I will be able to host all of you at the same time. You can log in using any Google account, and this is what I will do now and show you the address later. Okay, so I'm already logged in, so I'm gonna log out to make sure you get to see somewhat similar thing. You visit a web page and you simply press login. And this is the experience I wanted for my students, because I tried to make them install this on their own, but since I was a math and physics teacher in high school, it is not the main content to do programming and computational thinking, so this had to be quick. We couldn't set this up to handle a whole course of it, then it would be okay perhaps to take that time, but this had to be a smaller part. it had to be quick. So this is something similar that I got running for them. They log in and they have access to things. If you would do this later, you will find a folder which says README. You can open it, and you will find a README. You can open it as well. This is what you will see, and I will show you 4 demo notebooks that I have made. And let's see. Let's start with the use PDF instructions demo. So let us not invent everything again. Let us use great educational materials. And a friend of mine in Sweden, a teacher, has made a big PDF with a lot of exercises to do programming in math. So the book is called Programming in Maths, but it's Swedish though. So let's download this from the notebook. Downloaded and saved. Let's open it. Oh, wrong folder. I'll make this slightly bigger if I can. Cannot. Okay. Use PDF instructions. Oh, okay. And I will open the PDF like this. And what I'm suggesting is that you can have a PDF next to, since this is a book about programming instructions. I'm trying to drag it. Okay. Okay. I'd like a mouse. I managed. Victory. And I will open, for example, a workbook. So the way I imagine you could use a PDF like this is you will take an exercise, look at it, read it, and for example on page 27, there are great exercises. So let's use them. This is the exercise, and this is my workbook. And as a student, I could implement the code that are suggested I should do, and voila. And what more can you do as a teacher using Jupyter notebooks? Well, you can also, let's go to README, and I made, as a math teacher, I wanted my students to practice on very simple things so they don't have to think about them. For example, how to differentiate and integrate. What are the rules? So I made a notebook that uses SymPy and some LaTeX to generate stencils and some instructions, and I run all this code, writing a PDF. 2 PDFs were created. Let's look at them. Generate stencils, output, and another one here. These are the generated stencils that you can then print out and just train on the very basics, so you don't have to think about it anymore. And what do you say? A solution. Which these are randomly generated to make the students, they can't cheat, they just have their own stencil. Okay, let's go README. My main notebook that I've spent most time with, because I wanted to showcase to my school that this is possible to create great content. So I put a lot of effort in trying to help my high school students that had learned about how to differentiate and stuff. What are the basic concepts which is used in machine learning? And there is an algorithm called gradient descent. So this notebook contains some videos, so I hope to make the students interested. Why should they care about machine learning? Well, because computers are beating humans in computer games. They care about helicopters starting flying and such things. And if you have the infrastructure to use a notebook on a large scale, the educational content you create has so much more value than if it would be used on a small scale, right? So if you're able to scale something up, you're able to produce even higher quality content. And this is my best attempt on this so far, but I've learned a lot since. And so I provide some structure to create 3D graphics from a mathematical function that the user is supposed to define themselves. And if they do it right, they get pass. If they do it wrong, they change the function to something that wasn't specified, they fail and can see another output. Let me return this so I can. So it says begin solution, end solution there. It's because this is a teacher version, which is containing an example correct answer, which will be stripped out for the students. So in this notebook, it is possible, I think, to combine educational content that is great, make something even greater, and hopefully make it available to as many as possible. That is, if we can manage to select the gems that are high quality, we are able to produce awesome educational experience for our students. I would like to make a shout out to the producer of these two videos, which is, if you recognize this, it's 3 Blue, 1 Brown on YouTube, creating the best math videos I've ever seen. I'll run through. Okay, so if you'd like to do so, you can go to jupyter.se, which is my private just hub for the moment, a demonstration purpose. Jupyter.se as in Sweden. I would like to now introduce Jessica to speak about my binder.
So just to show of hands, how many of you have used mybinder.org? Okay, great. So this is going to be a reintroduction for many of you to mybinder, and for those who are new, I hope that this intro to Binder gets you interested in putting up content on Binder. How many of you have published a repo on Binder? Okay, great. So this is a good audience, I guess, to talk about sharing repositories with Binder. So Binder is a project that comes out of the JupyterHub team. Myself and Erik and Carl are some of the maintainers of Binder. BinderHub is the open source project. Mybinder.org is the deployment. This is what the URL, or this is what the web page looks like. And so we have a form here. The form has the name of a GitHub repo or URL, so it takes any Git repo, and we can specify a tag or a branch or a commit, and a path to a notebook file. And by clicking the button launch, we end up building a Docker image of this repository, and we get transferred to a JupyterHub instance of this Docker image. So Binder is actually a combination of projects. It's a joining of the project JupyterHub, which Erik has just shown you, and repo2docker. How many of you are familiar with repo2docker? Okay, so repo2docker is a project that I hope all of you learn more about. It's a project that you can use to build Docker images off of any Git repository. I'm just going to pause what I'm doing and just go straight to the repo. Oh, I'm just going to go to the there. It's going to the URL for the documentation. This describes how repo2docker works, how these Docker images are built in Binder, and this is also really useful for anyone who wants to make their GitHub repositories reproducible. We have some work on that. It takes standard files such as a requirements.txt or an app.txt or an environment.yaml, and it builds a Docker image around this. So this is a project that is very near and dear to my heart, and I hope that you all learn more about it. But this is one of the underlying tools in addition to JupyterHub that we end up using for mybinder.org. So this is what it ends up looking like. And I'm just going to take some examples actually from the Binder ecosystem. Actually, I think some of the maintainers are in the room, so thank you for doing this. I basically took the Google Analytics data of
popular binders, and I looked for ones that were particularly related to education. A lot of our binders are related to teaching people how to use a new set of open source tools. So for example, we use Binder to share IPython with people and say, oh, if you want access to IPython, this is how you would use it. And there's also binders that are associated with particular educational content. So these are two examples that are particularly popular. So I'm gonna go, actually, I think Alan's in the room. Thank you for this binder. I'm actually going to go to this now. So this is what the repo looks like. And we're actually going to go directly to the content. So this is the URL. And again, thank you for making this available, because we are now going to see what this looks like. So I'm actually now going to this notebook. This is if you're familiar with NB Viewer, we're using NB Viewer again to give people a preview of what this looks like. And so this is also a JupyterHub-like experience. We don't have to install anything. Everything's just ready to go. So if I run everything, we have access to the computational tools of mybinder.org, and no one has to install anything. The kernel is totally live, and it's available to the general public. So for example, we don't have sound. Oh, well, there is audio in this. Unfortunately, I can't feature it. But if any of you end up clicking on the same link, you would have that same experience. So this is very similar to what you would see with a JupyterHub instance. The only difference now is that anyone can put any content from a GitHub repo or Git repository that's available online and use mybinder.org to share this. The only thing we need is to make sure that the specifications of the environment are enough to run the notebook. So I'm just going to leave this. Another example, actually, that is not in the room as far as I know, unless there's someone from the Seminole County Public Schools. The Seminole County Middle School actually has put a lot of their content available online. I wish that they were here. Their notebooks are actually very popular. I'm guessing that they're using a lot of these notebooks to teach middle school students. I unfortunately have not been able to get hold of anyone, but this is what I've found so far from a newsletter, that they're using this for 6th and 7th grade students, and they're using this to teach science across the county's middle school system, which I think is particularly exciting. So thank you, Seminole County Public Schools. I wish you were here. I think this is a really exciting use of Binder. And so I think, so one of the things that I would want to mention again is that this is part of a broader ecosystem of educational tools within the Jupyter ecosystem. We are not just the only ones who are using these tools. We end up having, lots of different educators here. Many of you are in the room who have already given talks. Please look through the schedule and go to other people's talks. I think this is particularly important. Some of the other things that are coming out of the Jupyter ecosystem that I wanted to feature as an interesting alternative is IBL Education is also has a project called Jupyter Viewer XBlock, which is an alternative if you don't necessarily want people to be running computation on a JupyterHub instance. This leverages the Open edX platform, which is particularly useful for MOOCs. And then they're also using NBGrader, which is a project that's out of the Jupyter ecosystem, and modifying it to be used for Open edX as well, which is particularly interesting as it doesn't require you to deploy your own computational resources. So if you don't necessarily want to be using Binder or do your own Binder deployment or put things up on Binder, this is another interesting alternative. Please find Lorena and her colleagues to learn more about it. And again, I think this is where we can start taking questions and start concluding. Please get involved. We love contributions. We want to be able to continue this conversation with all of you. Some ways to get hold of us is we have Gitter. This is a chat forum for us. We have 2 channels. There's the JupyterHub channel, which is for discussions specific to JupyterHub. We also have a binder channel, so if you're interested in putting up your own binder deployment or putting things on binder, feel free to chat with other contributors or maintainers that way. We also have mailing lists. There's a BinderHub mailing list and a Jupyter mailing list. To deploy your own JupyterHub, we have instructions from 0 to JupyterHub. If you want to deploy your own BinderHub, we also have instructions on Binder's Read the Docs page. And I think that this starts to get the conversation going about various tools for using Jupyter notebooks. This is Carol's lovely slide. If you have anything else to add with this, Carol, I think this shows how much we love our community and how much the Jupyter community has been able to use Jupyter notebooks to do very interesting and exciting projects in education. So please, let's keep the conversation going. In terms of other people we want to mention, the San Diego Python group, we want to send our thanks to them. Demba Ba gave a great talk last year and has been doing really great work in Jupyter Notebooks for Education. We also have, is this pronounced OKGo? Okay, there's OKGo and Anne-Marie Thomas. Carol also mentioned Jason Moore and Quant Econ. Project Jupyter, again, we are particularly involved with and are thankful to the rest of the members of the community, including all of you. We also are particularly thankful to people who contributed the content that we ended up featuring in these slides. And again, as I said, these are some of the members of our team. This is not necessarily comprehensive to everyone, but this kind of shows some of the people you might see if you go and find us on Gitter or GitHub. Hopefully, we'll be able to maintain the conversation that way. Again, these are additional ways for you to get hold of us that I just went over, and I guess we can keep talking from here. So thank you. One question?
Questions?
Awesome stuff. Great. Thank you so much for all the contributions. One of the themes that kind of kept recurring was language. It was really cool to see notebooks in another language. I've never seen that before. But then, the children with English as a second language, that's what I'm very interested in. And how do the computational narratives kind of facilitate or grease the wheels where language falls short? Is there some benefit?
Yeah, I mean, obviously, you would like content in your native language. That's not always possible, but when I was doing traveling around Asia and speaking at different Python conferences, what I was finding was a huge usage of Jupyter. Sometimes, the computer code and whatnot is more universal, or math is fairly universal, so it was not as much of a language barrier. It was maybe more of a language barrier when I was in Taiwan and they had one track that was in Mandarin, or Taiwanese, I can't remember. And Google Translate, we had the video up so we could look at the slide deck. And it actually did a really good job, surprisingly. But yeah, I mean, it would be great to have language plugins and things like that. And I think with JupyterLab, that's a possibility down the road. And, much like in the Python community, we have contributors that are doing that, so.
Unfortunately, we're out of time. Let's give a round of applause to our speakers.
What was Elizabeth's question, just out of curiosity?
Do you have any exposed metadata on mybinder.org to gather this all repositories?
We do, actually, and I will
But we do keep privacy of, yeah.
We do. We have like high level stuff that we can. I think that's publicly available.
So we'll to connect that, like the Express session about having a discovery interface.
Yeah, that's something we're thinking about. That's definitely something that's like we're definitely interested in.
Thank you for coming. Awesome.
Please give me a round of applause to our speakers.